Hello everyone, my name is Jacob Tufts, and this is my presentation on the Memento pattern. Now, the Memento pattern, the intent behind it is, this is a definition that I found online. Without violating encapsulation, capture and externalize an object's internal state so that the object can be restored to this state later. So, I'm going to go through this definition piece by piece, starting with what is encapsulation and why do we not want to violate it? Other ways to think of this are as a magic cookie, quotes, that encapsulates a checkpoint capability, and it also allows you to promote undo or roll back to full object status. So, I'm going to go through examples later on, but examples would include like the Windows undo button and redo button. So, what is encapsulation? In the case of the Memento pattern, encapsulation refers to a language mechanism for restricting direct access to some of an object's components, such as the state of an object. Violating encapsulation is bad, especially for the security of a program, because not only does doing this allow other classes, such as clients, to view all of the implementation details of the class, and thus make it far easier to attack, it also gives you less control over coupling in your code. Now, if we didn't care about encapsulation, the Memento pattern would be a lot simpler. You could just make all of the variables inside of the method you wanted to save the state of public, and then use a caretaker method to snapshot those various states. But since we don't want to violate encapsulation, we have to do it a slightly different way. So here's the UML diagram for the Memento pattern that I found online. Now, the originator is the object that we want to save the state of. Memento is the save as of a state. And the caretaker is what actually triggers the originator creating mementos. Now, as you can see, in the originator, we've actually included two different methods: setMemento in Memento and createMemento. SetMemento allows you to create. Let's start with createMemento. createMemento allows you to create a memento object, and as you can see here, it returns a new memento with the state of the originator. setMemento, on the other hand, allows you to reload a state that you saved a memento of. So in this case, state equals the mementos state. Mementos get state function, because we don't want to have the state be public. So we have a getter and setter in the memento. And the caretaker is just kind of there. We're going to discuss that more later on. Now, let's do a brief implementation exercise. From sourcemaking.com is where I'm getting this from. So, let us say that we want to store a single integer to represent the state of a class called number, and that number has the ability to double or half the integer that is stored within it. We also want to be able to undo any changes that occur within number to the previous state, thus why we're using the Memento pattern, and we wish to do this as many times as we wish. We also want to be able to redo said changes. We will treat number as the originator class, and create a caretaker class called command that will be able to undo and redo changes that number makes to itself. We will also create a memento class to store the states of number, of course, because it's the Memento pattern. So let's go run through the code of number class. We have the constructor here, value is just the state of the object in this case. It's an integer, and that's why the class is called number. We have our double and half functions. Then we get to create memento, which returns a new memento based on the value that is currently stored in number. And then reinstate memento allows you to change the value stored in number to the value of a memento. Sounds pretty simple. Things get a little more complex once we get to the command class. So we have a list of mementos because, remember, we want to be able to undo as many times as we wish. This isn't like save files, for example, which can retrieve the state of an object. We're creating a list of saved states that we can go back to any of them. And we're doing it every time a change is implemented. So, in order to accommodate this, we have a memento list. And the number of commands, num commands, is just, I believe that's just the number of mementos. Yes. So, receiver, in this case, is just the number variable that this command class points to. So, the caretaker class command orders the memento class to create a memento, which is then stored in the memento list. And then command list, and then we have a command list with the number of commands, and that equals this. High water is the limit on the number of commands that we are allowed to do. So when I said limitless, I actually meant limitless in terms of high water. So if you only want to store like 10, you can set high water to 10, and then it will store exactly 10 commands, or 10 commands or less. And then after we order the memento, the number class to create a memento, number of commands is incremented, and then the number of commands is incremented, and then that corresponds to the number of elements in the memento list. So now we have our undo function. So if we haven't issued a command yet, we don't want to actually do anything, because then there is no command no previous state that we can implement. So we see out a message that says we're attempting to run off the end, in this case off the beginning of the memento list. So otherwise, we continue as normal. So the command list, number of commands minus 1, that's the previous command, is the number class